Hello, I'm Lak, and I lead the team that's putting together this course on machine learning for business professionals. Welcome. This is the third module in the course, and in the first two modules, you got an introduction to machine learning. That ML is a way of applying standard algorithms to large amounts of data so as to generate predictive insights repeatedly. So that was a definition, and in this module, we will look at how to do machine learning. You will learn how to create labeled data, how to train machine learning models, how to deploy trained models, and how to evaluate models. We'll also continue adding details around how to do AI responsibly. So in this module, you will learn how to think about models and how to avoid creating or reinforcing bias. Employing machine learning requires going through a number of phases, and it's important to know at the start what they are and why they're important. In this module, we will work through the phases in the order that would normally take place in a project, with one exception. Collecting data, we will cover that in Module 5. So for now, I'll assume that you already have data lying around and start with the data labeling phase. Recall that machine learning involves learning from examples. An example consists of labels and features. A label is just the true answer for an input. In this case, fractured is a label for this part. If we're trying to predict how much a customer in a bank will deposit in a given year, the amount that was actually deposited by that customer in that bank in a particular year is a label for the example. And when we train a model, we compare the prediction for that example against the label for that example and use that information to update the model. Labels can be either numbers or they can be categories. The amount that somebody deposits in a year, for example, that's a number. Whether that amount is high or it's low, that's a category. In machine learning, there are special terms for problems that are framed to use numbers as labels. They're called regression problems. And if you've taken statistics before, you've probably seen the word regression. When problems are framed where the machine learning model predicts a categorical value, then these are called classification problems. In many ways, these are just implementation details, and you can simply think of whatever is being predicted as the label. Just remember that a machine learning model can be trained to predict either a number or to predict a categorical value. So the label is a correct answer for the example. It's what we use to train the model. When we train the model, we also tell the model a number of features of the example. The features are the inputs to the model. Now, we're probably used to seeing features used in the context of products, a shiny new feature. But the actual definition of a feature simply means a distinctive attribute. So in this case, a feature is a distinctive attribute of the example, and that's what the model uses to learn how to do predictions for that particular example. So each input has a number of distinctive attributes. In order to train the sorts of models that we consider in this course, every example needs to have features and a label. There are other forms of machine learning that don't require a label, but they're less mature, and so we don't consider them in this course. Ultimately, features are descriptions that provide enough information about the example so that the model can figure out the correct label. In the case of images, the pixels of the image might be enough as features. And in the case of speech, the audio signal might be enough as features. But usually, it's helpful to have other information about the data. So that's called metadata. And so, for example, knowing whether the photograph was taken on the conveyor belt or in the furnace could be helpful.